So let's look at, ooh, do you see in the statement what's the most important word? I put it in all caps. Not. They love to do that to you. They love to put the word not. Shows up quite a bit. So we're trying to find the one that's false, right? All of these are going to be true, and only one of them is going to be false. So let's write true, false next to each one. The measure of angle H is 62. How do we know? How do we know if that's 62 or not?
62 measure D.
D is listed fourth, and H is listed fourth. So is the measure of angle H 62? Absolutely. That one's true. Okay, B. Ooh, this one's kind of tricky. It's a proportion. AB is to EF. Okay, we're doing good. First, second, as DC, third, fourth, is to HG, third, fourth. That is looking true. Looking mighty true. What? Fourth, third. Yes, but as you know, when you name a segment, the order doesn't matter. Okay. AD is congruent. That's what this symbol means. Congruent to EH. AD is the same length as EH. Now, I agree that AD is listed first and fourth, and EH is listed first and fourth. But does that mean that they're congruent? No, it means they are proportional.
Yeah.
So there's our false. ABCD is 3 times the size of EFGH. How would we find that out? That's called something that starts with, what does that mean?
Scale factor.
That's called a scale factor. How do you find a scale factor? This was important from last week.
Multiplying or dividing.
Right, but how do you find it? I told you like a fraction, something over something.
Old over new. No.
New over old, but I don't teach it that way. I always say second over first. So that's fine. So if we're going, let's see, the scale factor is 1/3. The scale factor is 1/3, 2 over 6, but they're saying that this one is 3 times bigger than this one, so it's a true statement either way. All right, so the answer to the warm-up was C. Okay. All right. Yeah, we got it. Cool. Okay, take a look at these triangles. All you have to do is look at this slide. You don't have to write anything down. Just look at these triangles and decide if there is a conclusion you can draw. Something's happening in some of the triangles. It's not happening in the other triangles. And there's a theorem that describes what is happening in certain triangles there. Look at the side lengths and compare them in the different triangles, the different numbers up there. Compare those numbers. Specifically look at what this segment is doing to the side. Look at 5 to 7 and 6 to 5. Is there any pattern there? Look at 2 and 4 and the 5 and the 10. The 2 and the 4 and the 6 and the 1. 3 and the 6 and the 4 and the 8. Can I see what's going on in certain triangles but not in the other ones? John, what you doing? Of the 4 triangles, which ones do you think there's a segment drawn that divides the triangle proportionally? That's what this whole day is called, triangle proportionality theorem. Which ones? Divides it proportionally. Second top one. Thank you, Alex, for speaking up. That is totally one of them. What's the other one? The first bottom one? Yes. Ding, ding, ding. Now, what do you think is special about these two that's not true about the other two?
They're slanted.
Slanted? Okay, so these two are slanted. So what could we say about these two? I'm looking for a certain word.
Parallel.
Parallel. Very good. So, if you split a triangle and your side is parallel to the third side, then you're going to split that triangle proportionally. It's going to be a proportion. Look, 2 times 2 is 4. 5 times 2 is 10. 3 times 2 is 6. 4 times 2 is 8. Now, it's not always going to be times 2. I don't really like how they did that with 2 both times, but it could be times anything. It will split our triangle proportionally. So if you can read that, that would be your theorem. This is what you would write down in your notes. If a line parallel to a side intersects the other two sides, then it divides them proportionally. If-then statement. It's conditional. If a line parallel to a side intersects the other two sides, then it divides the sides proportionally. So you know a conditional always has an if and a then, a hypothesis and a conclusion. So hypothesis is, okay, if they're parallel, if the arrows, then they're proportional. If, then. So this is the only words we're going to write. The rest of the class will be actually solving things. We'll actually use the theorem. We'll have to write all these words down. And this conclusion over here, it's saying the red over the purple equals the red over the purple. So it's teaching you how to set up the proportion. So we're gonna obey that theorem the whole class. That's the converse. You don't need to write it down. It just switches them. Remember converse, reverse? You'll need to know that for your final. But it says if the sides are proportional, then that segment's parallel to that third side. So it just switches them. All right, let's try some. You can draw that picture in your notes. I'll give you time enough to draw it. And we are going to find the length of EC. So we are going to find X using our brand new theorem. The theorem says if DE is parallel to BC, which they are, then our segments are proportional. So we're going to set up a proportion. Let's start here. 32 is to, now the theorem says to compare this with the side, with the portion of the side with it. Okay, so 32 is to 24 as, that equals, as 40 is to X. So I'm just putting 32 over 24 and 40 over X. So everyone do that. Go grab that calculator if you haven't done so today, which it looks like not many have. And cross, multiply, and divide. 32 over 24 equals 40 over X. The sides get split proportionally. So how do you cross, multiply, and divide? Y'all should have done this a lot on Friday. Right here, 24 times 40, enter, press enter, what do you get? 960. And then you do divided by 32. So you cross, multiply, and divide. Final answer? 30. So this segment, even though it doesn't look like it, is 30 units long. X is 30. EC is 30. So we'd write our answer like that. EC is 30. What's up? Okay. Next one. You can draw it in your notes, or you can just write the proportion. Use our new theorem to write that proportion. Something is something as something is something. Finding the length of segment R in. If someone has RN after their name, what does it stand for?
Right now.
Registered nurse.
Right.
Right? No, like when they have, it's like a title. All right. John, set me up a proportion. Start with 8. 8 is to what, John? Well, let's keep it on, okay. As, yeah. You made that sound difficult. It wasn't too bad. Cross multiply. Geo, what'd you get?
I got a decimal.
Okay, we don't mind decimals. Decimals are okay.
Okay, 6.25.
6.25.
Yeah.
Any objections? 5 times 10 is 50. 50 divided by 8 is 6.25. So you multiply 5 times 10. And you divide by 8. That is perfectly fine. This is RN. Hey, in the real world, segments will not always be whole numbers. They'll probably very rarely be whole numbers. Try again. Find the length of CY. The more you practice, the easier it becomes. Celeste, can you set up a proportion? Wonderful. 9 is to 4 as 10 is to x. Alex, tell me what you got. Yeah, 4.4 repeating, huh?
Yeah.
Don't get that? Okay. So, the thing is, if you put 4.4, you have approximated your answer. If you want to be exact, how do you turn that into a fraction? Math, enter, enter. Thank you. So if you go math, enter, enter, the full answer would be 40/9. Is it also 4.4? Yes. But this is approximate and this one's exact. Approximate, exact, approximate, exact. Who wants to be approximate? Exact, right? You want the exact answer, not the, is kind of the answer. Okay. Uh-oh, change it up on y'all a little bit there. Yeah, I think I'll need to take that away if we're not using it. I think we changed it up on you a little bit here. You're trying to find XD, so I'll put, well, that's confusing to put an X there. I'll put N. You're looking for N, and you're going to have to do something first. Is that how I talk? Jonathan, what do you want to do first? Thank you. We are going to take 30, and we're going to subtract 18, and we're going to get 12. We needed this 12. You can't use the 30. The 30 is not a part of, it's not a partial side. It's not splitting it up. See how we said the theorem says, hey, this segment splits the triangle proportionally. Well, we don't want the whole side. We want the parts. So we're going to say 12 is to, everybody? 18 as N is to 30. We had to do 30 minus 18 because we could not use an entire side. We had to use partial sides. Trinity, what did you get? Sorry, what? I don't think it's going to be bigger than 30 if we use reasoning. Let's see. 12 times 30 divided by 18. You flipped it. Okay. What's the answer, guys? Yell it out. 20. N is 20. So, yeah, look at your picture. 12 is less than 18, so this one's going to have to be less than 30. Okay. Ooh, real world problem. Watch out. On the map, 1st Street and 2nd Street are parallel. What is the distance from City Hall to 2nd Street along Cedar Road? It sounds like a lot, but you know what? It is no more than what we've been doing. So, find the distance from what? City Hall to 2nd Street. Here's City Hall. Where's 2nd Street? Not the first one, but the second one. So we're going from A to B. We're trying to find from A to B. Now we already know this is 2.4. So we need to find this little distance right here. And we can just use proportions like we've always been doing. Seth, set me up a proportion. This says 2.8. This says 2.1. Wait, where's the 2.5? Okay, we're going to stay on one side of the triangle at a time. So 2.8 is to 2.1 as, there you go, that'll work. He went this way this time, which will work as long as you go that way both times. Cross multiply on that calculator, please. Helen, tell me what you get. Oh. 2.1 times 2.4 divided by 2.8. Try again. Okay, cool. Now, the worst thing you can do is stop right there. That's not the end of the problem. That's not what I was asking. If you wrote that down, that's the distance from City Hall to First Street. But we're walking further than that. We're going to 2nd Street. So what do? Add 2. I know it's hard to read these. It's a 2.4. Add 2.4. Final answer, 4.2. That is the distance. 4.2 miles. Would you walk that far? Yeah.
Nope.
Have you ever walked 4.2 miles?
Nope.
Have you ever ran 4.2 miles?
Nope.
Have you ran more than 3 miles at a time? Yeah.
Nope.
Cool. Some of us have.
Halo.
Oh my gosh. Video games don't count. Does the triangle proportionality theorem apply to PQR? We're not going to solve this. We're just going to talk about it. Hey guys, we can't just use this theorem anytime we want. And that's the key of this lesson. We can't just use it anytime we want. When can we use it?
Parallel.
When it's parallel. Now, how would I be able to figure out if 2 segments are parallel? You're right, it has the arrow. These don't have the arrow. But we put it on the coordinate plane for a reason. So there's no arrow. I don't know if they're parallel. Could I find out?
Yes.
Using what? Starts with this.
Yeah.
Using what? Slope. Using slope. If I find the slope of PQ and the slope of MN, what would need to be true if they're really parallel? Same. Now, if they were perpendicular, it would be opposite reciprocals, but we're trying to make them the same. All right. Rise 1, 2, 3. Run 1, 2, 3, 4, 5, 6. Rise 3. Run 6. Ooh. What's the slope?
1.
6 divided by 3
Oh.
is 2. Geo was right. That's 1. Rise 1, 2. Run 1, 2, 3, 4. Rise 2. Run 4.
1/2.
Oh my goodness. Are they parallel?
Yeah.
So could we use the theorem?
Yeah.
Yay. Everybody's happy. Okay, we're going to do this last one, and I need to say something very important about this one. You can use the triangle proportionality theorem on this segment is to this segment as this segment is to this segment. What you can't use it for is the base right here and here. You cannot use it because a side has not split your triangle in half for those. So let's do X first, and then I'll teach you how to do Y. It's a different process, okay? All right, set me up. Alejandro. Now, this is X, so let's just call it a new variable.
W.
Okay, 12 is to W as, Alejandro, 15 is to 6. Let's start there. That's our easy one. Go ahead and do that. Cross multiply.
I got it.
You got a decimal again. Oops, pesky decimals. Richard, what'd you get? So you do 12 times 6 divided by 15. Times 6. Enter. Divided by 15. There we go. What is it? 4.8. So right here, this is 4.8. So Trinity, what is X? Okay. Did you write down what X is on? What? 16.8. All right. Now let's find Y, which is the more important one. I need everyone's full attention to find Y. Okay. I'm going to get rid of all that. Get rid of that. Okay. I'm going to write a proportion, John, and I'm going to start it like this. 10 is to Y as 15 is to, and I want you to be really careful. So, I said 10 is to Y. This is the entire bottom of the small triangle, and this is the entire bottom of the big triangle. Then I said as 15 is to,
12.
and we're not going to say 6.
12.
No, we need this. See how I did the right side of the small one? Now I need the right side of the large one. We have to add them together. 21. So to find y, you do not use the triangle proportionality theorem. You just use similar triangles. Okay. Cross multiply. Yeah, what'd you get? 14? All right. And y is 14. Questions? Ready to practice?